Hello and welcome to everybody. Thanks for taking your time to join this CPD session on storm and detention tanks. It's a little introduction to training and some housekeeping. First of all, I'm John O'Grady, Business Development Manager with Carlow Concrete. We're a market leader in UK and Ireland in water retaining structures, particularly precast concrete tanks. So we have a few learning objectives. So by the end of this session, hopefully, you'll understand a bit more on the design principles of precast concrete structures, manufacture and installation processes of precast stormwater detention tanks, a little bit about offsite manufacturing in the space and sustainability, compliance with standards and regulations, and we look at a good few real-life practical examples and the applications of a precast concrete tank system. So the agenda, we probably will get an hour out of it. If I'm going too quick or too slow, Sinead, feel free to let me know. And basically we'll cover the precast tank system, what it's for, why we use it, some installation examples. We will also talk about some other elements such as design and the production process. They'll be touched on. There's a couple of videos thrown in. One is an animated example of an installation. The other is an installation where we've a little bit of drone footage and stuff from a job in Leeds. And as I say, at the end, look, we may veer off this slightly, but at the end then we'll have a look at some Q&A, and there's a reflective statement. One moment. Yeah, so basically that is the view of a stormwater attenuation tank in precast. So it's basically a set of external walls, internals, and roof slabs. And there's a bit of a hybrid in it, in that there are some in situ elements, and we'll have a look at them as we go. So the question is, why do we need stormwater attenuation tanks? And there are sort of four things that we can look at. The primary purpose is really mitigating flood risk. So as urbanization and places develop, you can see in Ireland at the moment, we have a housing crisis, there's plenty of activity, but also commercial projects and infrastructure are happening. So a lot of impervious surfaces, such as roads and footpaths and buildings, prevent natural soil absorption of rainwater. So, with increased runoff, that can overwhelm drainage systems and cause flooding. So the purpose really then of the attenuation tank is to temporarily store the excess runoff during storm events, and then release it gradually back into the system once that sort of peak flow has subsided. And by controlling the flow rate, it reduces that risk of urban flooding. It's also important to note that, the building authorities in Ireland and the UK, stipulate a restriction of stormwater discharge, so that, on a developed site, it can't change the original state of the greenfield condition. So that's the main purpose of where it comes in. In terms of water quality management, attenuation tanks are there to also maybe enhance water quality, because as stormwater flows over urban surfaces, it picks up pollutants like heavy metals, oil, grease, sediments. So, if that's left untreated, that can get into water bodies and lead to degradation of aquatic ecosystems, and it can lead to water quality issues. So along with the tank, you're looking at things like petrol interceptors and sediment silt traps and things like that. So the quality of the water is important. In terms of the environment, the stormwater attenuation tank can contribute to, broader environmental sustainability efforts. If it's managed effectively, tanks can help restore natural hydrology of areas and allow ecosystems to thrive and promote biodiversity, where they can be integrated into green infrastructure such as parks, things like that. So that is a benefit. When we look at compliance and regulations, in many jurisdictions, you're dealing with regulations and guidelines on stormwater management, to see what the impacts are. So the attenuation tank serves as a practical purpose in flood control and water quality improvement, but also helps to comply with those environmental regulations that are put on councils and local governments, wherever that may be. So it helps them meet their legal obligations, and also aids, I suppose, resilience, infrastructure, and sustainable urban development, which is important. So, covering those four things, the tank serves, not just one purpose, but multiple, and I probably haven't covered them all there. But preventing flooding, improving water quality, and contributing to environmental sustainability is a vital component of an effective stormwater management system. And as I said, the challenge is that as urbanization and everything develops, it's not just residential. There's a lot of commercial stuff. There's a lot of infrastructure projects in play, whether that's road, rail, air, etc. So if we look at a little bit about design, so I suppose it's important to stress how significant the design aspect is, because without considered and compliant designs, you're going down sort of the wrong track. So what I would be familiar with would be the Eurocode 2, and British standards. So that would be BS 8007. So you got to come from a perspective always of compliance. Very important. Not all, I would say that not all providers start there. And I think, from my perspective, it's important that somebody does start there. And what happens is a drainage consultant or a civil engineering consultant will come up with a drainage plan for a site, and volume that's required in terms of stormwater detention, and maybe pass it to somebody like ourselves, who would then come up with a full set of general arrangement drawings and design calculations in line with those standards that I mentioned. Other things that follow them would be things like reinforcement schedules, penetration schedules. And in the design, sorry, I just skipped ahead, but in design, it's important to factor things like ground conditions. Not everybody will look at that. They might give you something standard and not sort of have a look at the soil conditions, the water table, etc., which are very important, and we'll touch on a little bit after. Looking at a typical precast concrete manufacturing facility for stormwater tanks, I suppose a benefit is you're operating in a controlled factory environment. So, accuracy will be improved versus other solutions. There'll be less waste, and everything is quite automated. The use of the hydraulic demolding process ensures zero damage to products with an early age concrete strength. A lot of it's important, I think, that it's a vertical process from design and through to the factory, so that you're not dealing with there's no reliance maybe on uncontrolled third parties. And some of the benefits, I suppose, of having that controlled and factory environment is, you know, we can harvest rainwater for concrete manufacture, because obviously it is something that is a little bit intensive on water in terms of production. And then once you're into production, it's important to track the quality. So having an in-house lab and testing technicians who are taking cubes basically every day, but there's I think a 24-hour, 7-day, and a 28. Those are the key ones that we would follow. So the system itself is a modular precast system. So you have different components I mentioned at the top, but it's quite simple. I mean, you've got external walls, but internal walls, and your roof slabs. The system being freestanding is important in terms of safety, in terms of speed. We will look at how that works in a moment. And it's a system that can be configured, you know, as desired. So it doesn't have to be a perfect square. It doesn't have to be a perfect rectangle. We deal with lots of irregular shaped tanks, whether that sometimes is to fit in with services, or could be trees, could be anything, a variety of factors. And then the applications, heavy duty and deep burial. So the standard offering would sort of be, the loading would be a 26-ton HGV axle load, which is a fully laden fire tender. But, you know, I've seen projects where all sorts of different loads are applied. If you're dealing with a highways project, you'll be into some LM stuff, or, you know, where we've dealt with airports, you've accidental loading of aircraft, things like that. But obviously, if the plane is hitting the tank, there's far more important things. But look, it is a feature that in design we can deal with lots of different sort of applications. Again, fully compliant to the BS and Eurocode. The system, you know, it says 0.8 to 6.5. 600 mil is incredibly shallow, but I've recently seen one of those up to 6.5. A lot of our own work would tend to be sort of 1 meter to 4, and then you'll have a few that fall outside of that. There's a couple of stats there that were gathered, I guess, versus a traditional in situ build of a tank. You know, you've got a large reduction in you know, labor, plant, site time, all those things sort of should be factored in when somebody is maybe selecting, you know, their options on a stormwater tank. So this is probably a little bit of the technical stuff. The product has to be designed watertight, and you'll notice from the pictures there that all the precast to in situ concrete faces are scabbled, and that forms a watertight bond. So in the graphic of the tank, you'll notice that between the external walls, there's a section, and that typically is 400 mil, but depending on the project can change. So what happens is we have projecting reinforcement that engages all the in situ concrete pores. We can also add a water bar or a hydrophilic strip, as it's called, and that's sort of a belt and braces approach. We used to use that or see that as standard. It doesn't have to be both. The scabbled surface is enough to ensure the water tightness, but on different projects, different consultants, different clients, they'll request it, and it's no problem. The standard design life of a system like this is 60 years. That can increase to 120 plus. It depends on the project and the client and what they're looking for, and sometimes the water company themselves. So the voids ratio is 95%, which is not bad. So we're maxing out storage as much as possible. Now I have a little video here it's an animation we did. It's about 4 minutes long, and we were playing with it yesterday, and we had a little issue, and we fixed it because there's a voiceover on it. And then, as all things with live television, when we tested with Sinead, the audio voiceover didn't work. So it's about 4 minutes long. I can talk over it a little bit, but mostly I'm going to sort of let you look at it, and I'll be going through the process of it after. So mostly I'll sort of keep stum on this one and just let you watch it. It's reasonably self-explanatory, but if you have questions, that's all good too. Oops. No, what's it again doing? I hope the video sort of was reasonably self-explanatory. There is a voiceover, and I think after we're going to share a working version so that you will have that. And as I said, I'm going to run through the steps of the install later anyways. Also in the statement after, I'd be happy to hear any feedback on, the video and what sort of you thought was good or bad. So this is just a very brief sort of snapshot of the type of companies that would use a precast stormwater system. So, as I said, it starts with consultants, but then you get into main contractors, and whether that be in a residential or sort of commercial sense. And there would be a lot of ground workers then that we would work in terms of install. But the snapshot there shows that, Irish Water is obviously one we would do a bit. We would do a fair bit with Yorkshire Water, Northumbrian, and Anglian, Southwest, etc., across the UK, where it's a bigger market, and probably 80% of our work is a lot of it with the likes of Persimmon, Keepmoat, Vistry, Barrett, those types. So that's sort of residential. You've got water jobs, then you've got sort of infrastructure stuff like at the Dublin airport. So like it's a multitude of different sort of applications and different sort of people who would use a system such as ours. So we'll just have a look at some sample projects in Ireland, just to give you just a brief snapshot of real examples. This is UCD Dublin, where they're expanding their campus. And this is a project that actually first crossed my desk in 2019, and then probably 2020 threw a spanner in the works, and it was installed just before Christmas. And I suppose we all know how long different projects can go on for various reasons, but it was a very sort of efficient 2-meter deep tank holding almost 1,400 cube of storage capacity, installed in approximately 4 weeks. Fun fact actually about UCD and myself is I was once on the architecture soccer team, which probably showed that I spent too much time there and not enough in DCU, but it is what it is. We had some fun. Moving on to Cork, this is one in Sarsfield Road. It's a good example of an efficient design, I suppose, but that is really site dependent on what you can do. But this was almost 3 meters, a little over 2 weeks to install, and good bang for your buck, I think, on this one. It's not, when you deal with this sort of system, it's not a sort of per cube rate across the board. You're going to have to factor in different things, whether it's sort of the configuration, different depths, different shapes, etc. If you have a very long, narrow tank, you're going to be using more external walls, which is, I suppose, the most expensive part of a system like that. In Cork, the council kind of is favouring our sort of solution over the last few years because of the maintenance aspect, and the fact that you can tell if it's working. There isn't a lot of maintenance to them. We can touch on that a little bit after. But in terms of this versus something like a crate solution, which silts up and is difficult to know if you're getting the capacity that you should get, etc. Dublin Airport, we've been heavily involved there. The North Runway, which hopefully will be used at some stage. We would have installed, I think, 9 large attenuation tanks, anywhere from sort of 5,000-6,000 cube up to about 10,000. And they were all airside, and that's the sort of accidental loading design stuff that I mentioned earlier. This one, thankfully, wasn't airside, but was completed, I think, about 18 months ago. If you're airside, it's quite onerous in terms of security, stuff like that. I think I spent 2 hours trying to get through security to have a 30-minute meeting one day. So that's just the joys of it. That's our finish inside. You'll see the stability feet. They will be removed to complete the job. Irish Water example in Clane village. It was right in the middle of the town. And that was project completed with coffees. Nice project. I'm showing you some big tanks. We probably have a few smaller ones. Yep. So this is a project in Dorset Street, so quite downtown in Dublin, with the Duggan Group, and they had four small tanks on this, and sort of shallow, from 800 mil up to 1.8. It's very typical. Like we get you see a good mix. It depends on the site. Some of those other ones I showed you were, big enough, but the average is sort of between 200 and sort of 1500. That would be a lot of it, and beyond that is a bit less. Albeit in the UK, there probably are bigger tanks on bigger sites. This job is literally on site at the moment. Sort of put in a relevant one. So obviously we had a couple of sunny days, which is unusual. But welcome. So the last tank on that site literally starts at the end of the week. And it shows, I suppose, the flexibility again of a system like this, where you can get it into tight areas, and also into downtown Dublin, as I say. This is one we did with a great team from BAM a couple of years back. There was, I think, three tanks on this one. The one in the picture, I mean, it's long and narrow, and that configuration, I suppose, is not ideal from a cost perspective, but sometimes can't be avoided. It's just the design in terms of the site is going to be what it is. We would always try and feed into, as early as possible, configurations and options, I suppose, just to try and get the most efficient cost-effective system, if you will. Again, a couple more images from the same site. Those are the smaller tanks. You're in and out probably in 3 weeks. This is a section across sort of how it goes together. And you'll have seen from the video, the first step after the excavation is to put in a 75 mil blinding layer. And that provides sort of protection to the exposed formation level, and provides sort of a suitable and clean working surface for the installation. After that, we're straight in with our external walls, and all those get placed around the perimeter. Once that's in place, then we will reinforce with 2 layers of mesh, top and bottom, for the base to be an in situ pour, which is, the standard would be 225. So you'd end up with sort of a 300 base if you add in the blinding. Once that's done, formwork is added to the stitching. As I said before, kind of 400 mil between external units. That gets poured, and then we're into roof slabs and the reinforcement of the same. It's a pre-stressed, it's 125 mil pre-stressed roof slab. And it's finished off with 125 mil of a in situ pour across the top of the tank, and that's kind of job done. Everything that you see will have been designed to those standards that I keep mentioning, Eurocode 2, BS 8007. So a feature, I suppose, unique to ourselves is that we use a stability device, just something we came up with that allowed us to have no props and still, safely work. We've used this system. Obviously, the height of the wall will dictate how large the stability foot is, but essentially, it allows us to level up the walls. And what happens is the unit on the inside of the tank gets cast into the base slab, and we remove the galvanized stability footing on the outside, and we finish that off by capping over the section. So it's a handy little system. It's one that we've used up to 6.5 meters on a project in the UK, which at the time was the largest reservoir in Europe, 60,000 cubic meters of storage. Those walls are 6.5 meters. There was a bit of wind up there in the Lake District, and we were still able to operate with our standard system. That's just how it goes together and how it's removed once we've done the base pour on the inside. So some site aspects and conditions that sort of demonstrate flexibility of this system. We can talk about soil types, and so it doesn't matter whether you've got compacted soils or loose cohesive soils. Precast tanks can be installed without disturbing significant areas and without using sort of valuable land space. Where you've got loose soils or varying conditions, it allows for effective utilization where other solutions or methods may fail. In terms of topographical variations, whether it's a slope site we can accommodate, or whether it's sort of low-lying regions prone to flooding, precast tanks can be deployed, allowing effective detention and, as you will have seen in the video, gradual release back to the natural greenfield state. High water table is another area where this type of system comes into its own. I mentioned, I think, in the design aspect, if somebody's engaging us on a project to design, manufacture, and install, the first thing we look at is obviously the current design drawings, site layout, etc. But also we request an SI report, and that has to be factored in so that we look at the ground conditions, is there a high water table, and that we can actively then design out any potential flotation issues. So that's an area that is quite good for that type of system. Again, another one is limited space and different infill conditions. In terms of space, we can manufacture to suit a particular site constraint in terms of space. And we'll see some examples of irregular tanks where that's been effective to allow a builder, let's say, get another 1 or 2 plots into it. So there's not really any blockers as to where we can put the tank, which again, maybe versus other solutions, it may have an edge. I mentioned the heavy load. So we often see that in terms of, again, it sort of feeds into the limited space situation. So, the fact that we can cater for whatever the required load is, it makes it suitable for installing under car parks, roads, where there's and also that helps obviously with limited space, but there's not too many blockers for where you can use the system. In sites where environmental protection is considered, the use of precast tanks minimizes land disturbance and preserves sort of natural water flow. So I mentioned it already, but can be designed to include features that sort of help filter pollutants. There's a cost and time efficiency. Doesn't have to be in remote locations. I mean, that is a consideration sometimes because they can be installed quickly, and it's especially beneficial in those sort of hard to access areas where conventional construction is difficult and might incur delays. But when you look at the system in terms of that sort of time consideration, it's a lot faster and cleaner and tidier than let's say than a traditional build. And also, in terms of the labor, a lot of the jobs are installed with a 3-man crew. I mean, 99% is a 3-man crew, so it's not very labor intensive that way. So you've seen a good few projects, so I'm not going to dwell on these too long. I'm just wary of time. These are some sample UK projects. This was actually the first one that Carlow Concrete ever did for Barrett Homes up in Yorkshire. You'll see on the left side, the tank is stepped. It was before my time, but would have been a reason for that, but it was not a problem to accommodate that. Another one for Barrett's in York. And this sort of shows you can see actually they've started in the top right picture to place roof slabs. And you'll notice there's a handrail around the top. So that's a fall protection, which is required on all the sites. We do plenty in the north of England, and it actually gets more rain than Ireland. Well, maybe on a par with the West, which is kind of a depressing thought. But look, we're in the sunny southeast at the minute, so we won't dwell on that too much. Another good example of where we've fitted into the site, and this particular job, I know they did get another couple of units on it, so we were happy to help. And it was probably early engagement in the design phase that facilitated that. This is just, I suppose, a smaller example. Top right, you'll see that's sort of the finish that we hand back, I guess, and the ground worker will then sort of take over, and they'll be on to sort of the backfilling element of the job at that stage, which we can touch on in a moment. Another irregular one, kind of quite a big volume on that 2600. I have another video, much shorter. This one, it's a little bit of drone and time lapse footage, so I'll just let that play for you. Hey guys, I hope that video wasn't too choppy. It was okay at my side, but one of my colleagues had his hand up, waving furiously that it was choppy. It was no good. So hopefully it was okay for everybody else. I'm going to have to start motoring a little bit because I'm just, as I say, wary of time. Basically, a flood alleviation tank is essentially, from my perspective, the same system, but sometimes on a bigger scale. Sometimes it's not on a bigger scale, but you'll see you'll see some projects here in the UK where we have provided water companies with flood alleviation tanks, and they have been more proactive than in Ireland in terms of combating, the weather events that we're starting to see a little bit more and more. We would like to see some of our councils in Ireland maybe taking action before we see more pictures on the news of places flooding. I'm just skimming through these. This is one where the site was actually tidal. It's by the River Weir, but we managed to design effectively. So, install procedures. You probably have a good idea of this already. As I mentioned, blind out the excavation first, external walls, so the perimeter. You can see the three operatives there. That's all we really need. In terms of plant, all that's really needed is a crane for a select number of days, which we program out, and a concrete pump for a couple of pours. So it's not very intensive in terms of plant. You can see the stabilizer that I mentioned earlier. Mesh into the floor, base pour into the internal structure. Those beams and columns they've got a tapered bottom to them, so a little bit of mortar, but they freestand very easily due to the design. There's our friend fixing the joint, which will then be poured. And once that's all done, we're into our roof slabs, reinforcement, and we do a roof screed to complete the project, basically. I've mentioned some of those reductions in different things. That tank is obviously not the one in the other pictures, but the one in the other pictures was actually the first job that we ever did. So I appreciate your time.